Hello everyone, my name is Shambhavi. Hope you all are doing well. Okay, so what are we going to do is that we will be discussing up the further different types of the cues which you were taking up into the previous video. Okay, I'll be just taking that further right into this particular video also. So let's get started up. So what I'll do, I'll just first of all brief you over that what we have discussed in, right? Then we'll be proceeding in further with the things. So we discussed about the cues that basically what are those. So we have just learned that cues are a sort of a linear data structures that follow in your first in first out rules. Right now there we are having some many different types of I'll say operations which we have in with the cues. The very first one is your NQ, which will help you to add an item into your queue, right? The DQ method, which we even used out. So yeah, in that same case also, it will help you to remove out any item from your queue, right? We were having front, so that front function was helping you to get out any particular front item from your queue. And if you talk about the rear, so yeah, again at that sort of time, it will help you to get in the last element from your queue. So that these were the four terminologies that were very important for us to understand while we were using the queues and writing in the programs for the same. Right, so even the time complexity for all of the ones, NQ, DQ, front and the rear, the time complexity for all of those is big O of 1. Right, so in that particular case, that is what all is about the same. Right, now implementation of the queues, you can implement that with different sort of functions, like you are having one as a list, then you have collections.dq and then you have queue.dq, right? So with that same as well, you can simply do the implementation of the queues as well at your end, right? So that is what is the very first thing that we have up over here into the queues. The implementation we have already learned that how do you implement. Further, I'm not going to take this particular thing. We will further proceed in with the other parts, right? Then now we just try to learn over that in total basically how many types of queues we are having in, right? So we have just learned in that we do have completely five types of basically we have five types of queues over here, right? So that five types of queues which we have in, it starts with our input restricted queue, right? That's the very first one which we have up. Further proceeding in, we are having the input restricted queue. It is sort of a very simple queue which we have up over here, right? Then we are having output restricted. Again, that is also a very simple queue. Proceeding further, we are having the circular queues, we have double-ended queues, and we have the priority queues. Priority queues are subdivided as ascending priority and descending priority. So we have already learned about the circular queues are what are those all. So it is a sort of a very linear data structure in which what are the operations you are having, right? What are the operations you are having? All of those particular operations are being performed based over your first in first out, that is your FIFO, right? Now then further we were having that what are the last position we have into that particular queue, that particular one is connected back again to the first one, right, for making it up a sort of a circle, and that is also called as a ring buffer. That is what we have here as a circular queue, right? So into that, what the benefits of a circular queue are basically when can you use those all out. So it's all about the very first one is my memory management, right? The unused memory locations into the case of the ordinary queues that can be utilized in a circular queue. So we learned in that, like, into a circular queue, what are the memory locations, what are the places we are having where the items get stored into the queues. So into that, if there is anything which is unused memory or anything like that, so it can be completely utilized into the circular queues. Next we had out the traffic system. So into that, what happened, that computer control traffic system we were having. So circular queues which are there, those are completely used to switch off the traffic lights, right, one by one repeatedly, and as soon as the time is set based over the same. Further we are having the CPU scheduling. So we have the operating systems which often help us to maintain a queue of the processes which are ready to execute, right, or which are waiting for any particular event to occur. So that was all about the circular queues. Even we have checked out the practical for the same, so that I'm not going to give a very quick review, that we'll be discussing up further, Right, next we had out our input restricted queue. So that is one of the input which can be taken from one side only, that's as I told you, from the rear, and deletion can be done from both the sides. You can do it either from the front or from the rear, right? Now any so this kind of queue, it does not at all allows your FIFO, that is a first in first out, it doesn't at all allows, right? So this particular queue, it is used up into your cases where you need out any consumption of the data, right? Maybe into the FIFO order, but there is a need to remove the recently inserted elements for any particular reason, right? And basically, and then one such case can be irrelevant data, which can be a performance issue as well, right? So that is where your input restricted queues work, right? So I hope we are pretty clear with the same. So what I'm going to do, I'm going to proceed in further. One second. Okay, so I'm going to proceed in further over here with the third type of the queue which we have up, and which we'll be discussing up. So that is my output restricted queue, right? That's my, yeah, that is gonna be my third type of a queue which we have up over here. So just a second, 1 second. Right, now into this particular type of queue, let's discuss that what happens in this type of queue. In this type of queue, the input which we have, the input can be, in this particular type of the queue, the input can be taken from, it can be taken from both the sides. As I was discussing in the input one for you, that in the input side, the input can only be taken from the rear side, right? But into this restricted one, output restricted, it can be taken from the both sides, either your front or the rear. And whatever is a deletion and a delete, okay, DEL, and a deletion, and the deletion of the element, right? And deletion of the element, it can be, and deletion of the element can be done from one side, right? So yeah, into this particular type of the queue, what happens, the input element which we are having, that can be taken from both the sides, either the front or the rear, okay? But the deletion of the elements, it can only be done from one side, and that is my front side, even not from my rear side, from only one side, right? So if we're talking about this particular queue, that in which cases it is used out, so we can write that this queue is used, this queue is used in the case where the, okay, this queue is used in the case where the inputs have some priority. This queue is used in the case where the inputs have some priority order, okay, priority order to be executed, okay, to be executed, and the input can be placed even in the first place. So okay, even the first place, so that it is executed first. So this is what happens to our output restricted queue. So into this type of a queue which we have in, so the input which we have in, that can be taken from basically from both of the sides, and whatever the deletion of the elements we are having, that particular one can be done from any one side. It can only and only be your front side, right? And this is one of the types of the queues that is used in the case. Now if let's say I have a scenario that where the inputs have some priority order, let's say I have priority order in the inputs which I have given up into this particular one, right? I have, let's say, priority order that maybe this particular one element should be entered in the first, or that particular element should be entered in the first. So that is a priority order which we have in. So if I have any sort of any priority order at any cost, at anywhere, right? So into that particular case, for getting executed and everything, so the input it can be placed even onto the first place only, so that it is executed firstly, right? So if you want the input even to be getting executed when you have priority order as well, so yeah, you can put that input onto the first place and that will very easily get executed. So this is the complete scenario, or I'll say this is the complete scenario way where you will require this output restricted queue to be worked out, or the basically things to be worked over here, right? Okay, great, now that's done. Now after this output thing, we are having the next type of a queue which we have in point number 4, and that we have already even discussed a name for the same, so I'll just like write it up correctly. One second. So that is gonna be my double ended queue. Okay, yeah, we will be discussing out this one, that is my double ended queue now. So let's understand what it is. So first of all, it is also a queue data structure. Okay, yeah, so it is even a queue data structure in which the insertion and deletion operations are performed, right? So that is like what we have up over here, that into the queues, whatever the types of the queues we are having, either input restricted, output restricted, circular, double, any type of a queue whichever we are having, that everywhere only the insertion and the deletion, right? Everything, every time the elements are inserted, every time the elements are deleted, all of the ones, right? So which one to use when, that I am already telling you all about, that which type of a one you have to use at what scenario or where actually, right? So that we are discussing only. So that is the one thing which we have up. I performed from the both ends, right? I perform from both ends, and that is gonna be my front and rear, both of the portions. So double-ended queue is also a type of a queue data structure which we have in, and into which what are the insertion we are having, what are deletion operations we are having, those are completely performed in from both of my ends, my front end as well and my rear end as well, right? Now what does that actually means in? So I'll just write that. That means we can insert both. We can insert at both basically either the front or the rear, any positions, front and rear positions, right? So that means that we can insert at both front and rear positions, and even can delete as well from, and can delete from both front and rear positions. Okay, one second, positions, right? So that's the very first thing which we have up over here, that into this particular one, that is my double-ended queue, right? So into this one, very clearly you can insert at both front and rear positions, right? And even you can delete from both of the positions, that are your front. Let me check in the spelling, FRONT, 1 second, right? Yeah, so there at that particular one, you can just delete it from both the front and rear positions. Both of the things could be done in, right? Now some more things about this double-ended thing. So if I talk in that basically, or we can discuss that since, okay, we can discuss that since DQ supports SUPP, right? Yeah, since DQ supports both your stack and queue operations, right? Since DQ supports both stack and queue operations, right, it can be used as both. Now DQ we have like learned right away a few minutes before I told you about the DQ, right? It is for deleting the elements. Now, as it is mentioned that DQ even supports the both stack and the queue operations, right? So it can completely be used as a both, fine. Even in the uh, basically even in the stacks also, and into your queue operations also it can be used in, right? So what are the DQ data we have and what happens to that? So the DQ data, is structure. um, okay, one second. So the DQ data structure supports clockwise and anti-clockwise. The DQ data structure supports up to clockwise and anti-clockwise rotations in, and what's the time complexity in which it does? So that is going to be my big O of 1, right? In my big O of 1 time, which can be used, okay, or we can write which can be useful in certain applications, right? Which can be useful in certain applications. Like now, what can be those applications? So that we'll discuss. But it can be used in certain applications. Also the problems where element need, the problems where the element need needs to be removed and or added, both ends can be efficiently solved using DQ, right? Now that's what is happening up is that into this one, that is our double-ended queue, right? So first of all, as I told that again, it is also a queue data structure into which the insertion and your deletion operations are performed very clearly from both the ends. It can be either done from your front end or it can be done from your rear end, right? Now into that particularly means that either you can insert the elements from the front or the rear positions, or you can delete in from either the front or the rear positions. That particular thing can be followed very easily. Now, since DQ which we are having, that DQ particularly supports the stack and the queue operations, right? It supports out your stack and queue operations, right? So it can be used as both. So yeah, in that particular case, you can use this particular one as both. So the DQ data which we have in, right? The DQ data structure which we have in, that supports clockwise and anti-clockwise rotations also, right? And the time complexity in which it follows both of the rotation is the big O of 1 time, right? Now that can be very much useful in certain applications, right? Also whatsoever the problems we are having, where the element that we are having, if it needs to be removed, right? Or if it needs to add both the ends very efficiently. So those all particularly things can be done with the DQ very, very, very easily. That is what we have up over here, right? That's one, I'll say one of the things which we have up into this DQ, that is my double-ended queue, right? Now once we have discussed about these things, now the term comes about discussing all about our priority queue. After that, we'll be seeing the practical as well for our priority queue. So priority queue, right? That we'll be discussing it now. So a priority queue. That is actually a special type of. A priority queue is a special type of queue, right? In which each element, a priority queue is a special type of queue in which each element is associated with a priority, and is served according to its priority. Right, now that is what happens in a priority queue. That into a priority queue, that is a special type of a queue, right, in which all the elements, or in which each and every element which we have in, that is associated with a priority, right, and basically that is served according to its priority, right. Now there are, as I told you, there are two types of priority queues, right, as we discussed. So if we talk about the first type of the priority queue, that is my ascending priority queue, right, my ascending priority queue. If we discuss about that one first of all, okay, now as we like only know from the name only the ascending, it means that again it has to be into the listed to the greater number format, right. So if I talk about that in detail, so whatever the element we are having, so the element can be inserted over here, element which we have up at this particular one in the ascending priority queue, whenever we are going to use this over, so the elements which we are having, that can be used in arbitrarily, okay, arbitrarily, yeah, arbitrarily, but arbitrary means that into the main that particular ascending format only, that particular one, but only smallest element can be removed, okay. What is this all about into the ascending priority queue? So what are the elements we are having? Our elements can be inserted in any format, right, basically you can put it in any format, basically like smaller to larger, larger to smaller, or any randomly also. So anything like that could be done in very easily, right. But if you want to remove out any element from over here, from here, right, so only the smallest element which we are having, that can be removed. Only that smallest element can be removed, not any other element can be done in from over there, right. Now if we take up a quick example as well, so let's say for example, right, so for example, okay, basically let's say we are having, for example, suppose we have okay, I'll say suppose there is an array having element, suppose there is an array having element 4, 2, 8, let's say, right, in the same order, right. Let's say in that put in smaller only we have an element 4, 2, 8, right. Now so while inserting the elements, one second, right, now while inserting up the elements which we have up, while inserting the elements, the insertion, okay, while inserting up the elements, the insertion will be in the same sequence, but while one second, but while deleting, the order will be 2, 4, 8, right. So as I was talking about over here, that into this respective example, whatever the elements we have in, maybe they are 4, 2, 8, right. So into that one, one second, INC are like that, perfect. So whatever the array we are having, like element is 4, 2, 8 into the same order, right. So here while inserting up the elements whatsoever we are having, the insertion that we have in, it will all be done into the same sequence, but while deleting the order, it will be done into a first of all in the ascending order, and the very smallest number will first of all be deleted. It's not like that you have written 4 comma 2 comma 8 and you want to delete 4 from here. No, that can't be done into this ascending priority queue, right? So make sure whenever you are entering out any sort of the elements or anything over here, right, and you, if you want to delete up over, you have used up the ascending priority queue, that particular method or the thing. So the very smallest number that you have into your complete maybe the numbers, that will only be deleted. The first deletion of the number will be that only, not any other number, right? So that's quite a simpler. Like if you want to use up the ascending priority queue and if you want to delete out an element, just simply do one thing. First of all, you can even sort up the array in the ascending order from smaller to larger, and yeah, that might help out, or that might work up for the things, right? So that is one thing which we have up into this one. Proceeding in down, we have the second type, and that is my descending priority queue. So descending priority queue, right? That's the other thing which we have up. Now talking about the descending priority queue, that we can as well work over that element can be inserted arbitrarily, as again as I like, as you simply do, or simply however you just like use up or anything like that. So yeah, here the elements can again, those can be inserted arbitrarily as well, okay. And but again we have a condition, because it's again going to be a sort of a different priority queue. So yeah, we have to fulfill out those respective conditions. So element over here can be inserted in any manner, but only the largest element can be removed first from the given queue. Now in descending priority queue, what will happen? Elements, those are all the elements which we have in that that can be inserted in any manner. As in any manner, if we're talking about, those can be inserted either ascending, descending, or randomly as well. So yeah, all of those particular things can be done. But whatever the largest element we are having, that particular element can be removed first from the given queue, without the removing of the largest element first from the queue. If you wish that the third largest or fourth largest should be removed, so no, that won't be done out. So I'll just show you the example for the same. Let's say if I write, for example, if you check about the example for the same, so we can talk about that that suppose there is an array having elements 4, 2, 8, again that same elements in the same order, like as it is written 4, 2, 8, in that particular same order we have the elements, let's say, right? So while inserting up the elements, I'll just write elements. While inserting the elements, the insertion one second, the insertion will be in the same sequence, but while deleting the order will be 8 comma 4 comma 2. It's as I was telling all about that in descending priority queue, you can insert up the elements in any manner, but only whatever largest element you are having, that will only be get removed first from the given queue. Without removing of that first element from the queue, nothing won't happen up, right? So as in let's say if I give you some example, so let's say basically there is any sort of an array which is having some elements like 4 to 8, right? In this particular same order you have those elements. So once you're inserting up the elements, the insertion which we have into that same sequence, that will be done. But once we are deleting up the elements from here, right? So in that particular case, basically the largest element which we have in, that is, let's say, my 8. So that particular largest element will only and only be deleted first, right? Other elements which we have in, those won't at all be getting deleted first of all. Let's say if you want that 2 should be get deleted firstly, no, that won't happen up, right? So that is what we have up over here. Now what are the time complexities we have in for the priority queues? So the time complexity for all the priority queues, that is basically like big O of log n only, right? That is basically the one thing which we have up. All the priority queues which we are having, the time complexity for all of them is big O of log n. That is the one thing which we like generally have up over here, right? Great. So I hope I am pretty much clear with this particular thing to you, all about the same, that what do we have up into this one, right? Or generally how do we do up the things into this priority queues and everything. So what are we going to do? We are going to try we are going to try writing up some practical implementations for our queue, right? Okay, so I'll just get down. What I'll do, I'll just try to comment up this whole program which we have written up till here, right? So what I'll do, I'll just help you out with a little bit the practical implementations of the priority queues, like generally how do we do the practical implementations of the priority queues and everything. Okay, great. So we are going to implement a priority queue in the Python, which is first of all manually a sorted list. So let's say priority underscore queue, right? Let's say that is one of my variables which we are having, and into that I have a blank list, right? Now let's say we are having priority queue. Okay, not queue won't be done. QUEU we can write in dot append. Right, I'm gonna append up anything, means I'm gonna add up something into this empty priority queue. So let's say I have a number, let's say that is 3, okay, and into that I have, let's say, a character which is A. Okay, done. Next is again the priority queue, and again I'm going to use up the append for the same, okay, and let's say it's 4 comma maybe B, right? That we can take up over here. Third, we are having priority queue, right? Dot, we are having append, right? We have this 5 comma 1 second, then we have up over here as C, right? Again we are having priority queue dot append. Okay, not let's say 5, I won't take it this long, I'll just put it up as 1, right? Again my brackets, and let's say this time we have 2, and that's, let's say, my D. Okay, so we are having up the elements inserted, or I'll say added up into my priority queue over here, right? Now if I want to resort up basically if I resort every time a new element is added, right? I just want to, let's say, reverse it once it is added or anything like that. So what I'll do, I'll just write a priority queue, that variable of me, dot I'm going to use up the sort function into that reverse, and that I'm going to set up here as true. So okay, T will be capital for my true. So what is this at my priority queue which we are having? I'm just using up the sort function for the same, and I'm just like writing up as reverse. I'm reversing as and a true, right? Now we'll go up my condition that while my priority queue, I'll just try to turn in my next item further. So next item is equal to again my priority queue dot pop. Pop means to remove, right? So yeah, pop means to remove, and I'm gonna simply print in that next item. Print next item, right? That is what we have up over here. That is what is the complete basically the complete program, right? So this is what is the very one type of a thing which we have. And now I will, if I try to run this all over here. So see, what do I have? It has completely been sorted onto my ascending order, 1, 2, 3 and 4. Rather, I haven't put this onto anything like order or anything like that, right? So automatically it has converted it onto my ascending order, because the order which I had put in was 3, 4, 1, 2, right? But that was arrayed randomly inserted sort of an on basically the manner. But yeah, here because this was my ascending priority queue, so into this particular practical implementation it has automatically sorted up that respective thing, right? So we do not need to do anything for this one right away. Okay, if I taken up a one other example, this one is the manually sorted, right? Now if I use the queue priority queue class for the sorting up of this one, right? So how do we do that? So yeah, I'll just write in over here. So first of all, I'm just import something. So from queue, I am gonna import up the priority queue. Right now, queue is my, you can say it as a sort of a library something, right? And priority queue is my other functions which we are having up into this one, right? So from my queue, I am importing up my priority queue, right? Now here I'm going to give it a name. Let's say priority queue. Okay, and I'm going to set that as like over here priority queue. I'm going to call up this particular function which I have put in up above. 1 second. Right. Now that thing is being done. Now it's the time that I'm going to again enter in the values over here. So priority queue dot put, right? Now inside that listen, now previously I was using the append, so it was adding up, right? Now when here I have used this priority queue function everything, so I can very simply use up this put function also. So priority queue dot put, and double brackets I can put in the numbers. Let's say I'm going to take in the same values, nothing sort of a very difference into both. So 3 comma, and let's say it's p this time. Okay, again I'm going to write that priority queue dot put, this time let's say it's going to be 1 comma r. Again priority queue dot put, and let's say it's gonna be 4 comma r this time. Okay, I'll give 1 space, and this time again we have priority queue dot we have put, right? And into that I'm gonna write, let's say 2 comma, okay, 1 second, 2 comma s. Right, so yeah, these are all of the values which we are having up, and I had just simply put them all of the over here. Now my condition will go while not in priority while not priority queue dot empty. So it means that up till the time this is not empty, right? I'll do next underscore item. So I'll do next underscore item is equal to priority queue dot get. It will help me to get in the next items. and I'll just simply try to print in up all of those next item which we have up. Right. So this is how I just have written up here for my queues for this particular one, that is my priority queue class. I'll just try to comment up this above program which we had written up, and 1 second, after that we'll run in further 1 sec. So yeah, now I'll just gonna run up this particular program from here, and let's check basically how our respective result is. So I'll just run it from over here only. Great. So yeah, see, now again it has sorted that particular array for me into the respective manner. Now it is sorting according to my first numbers which we are having, right? So if in any of you might think about that it is sorting how or what's the manner it is sorting. So let me tell you, it is sorting according to the numerical values which we have up over here, right? So yeah, that's the thing which we have up for this one. Now if you're talking about that, what are the applications of the queue, right? Now queues are basically a sort of a data structure that are used where or when we do not have any of the things that should be processed very immediately, right? But we have to process that in the FIFO order, that is the first in first out order. Basically like your breadth first search, if you have listened about that, BFS, breadth first search. So into that in first out order only works out. So whenever you are having anything into which you want to put first in first out order, FIFO, so there you use up this queue. Now the property of queue is that it can make you some kind of scenarios, as in like whenever basically a resource is shared among the multiple consumers, right? Basically like your CPU scheduling, disk scheduling and all those. So that is one of the scenarios or one of the cases where this particularly queues can help you out. Or if you have any data which is transferred basically basically the data is not necessarily received at any data, it is being sent out between any two processes, like a file input output, file IO and everything. So into that respective case as well, your queues can also help you out, or those are your applications of the queues. Right, so I hope I am pretty much clear to you all about that, what are these queues and everything, right? So what we discussed up today is all about, started from your output restricted queues. We learned that what are these. So into this particular type of the queues, the input which we have that can be taken in from both of the sides, and whatever is the element deletion, right? That can be done on from only one side, that is your front side. Right, now this queue which we are having, that we have used into this particular case where the inputs have some priority order for them to be executed, right? And the input can be placed even into the first place, right? So that it is getting executed first. So that is what is your output restricted queues. If I talking about the double-ended queue, so those are also a type of a queue data structure into which you have some insertions and deletion operations, right? Those are performed from the front end and the rear end, from both of the ends, right? It means that you can insert either at the front end or at the rear positions, and even can delete in either from the front or the rear positions. Now whatever the DQ we are having, that supports out your both stack and the queue operations. So yeah, again in that particular case, this can be used as either the stacks or the queue operations. Anyway, it can be used out. Now the DQ data structure which we are having, it supports the clockwise and anti-clockwise rotations also, right? And the time complexity for that is bigger of one time. It can be useful in many applications, right? Also the problems where with the elements are there, they need to be removed, right? Or need to be added at both the ends, and they can efficiently solve using the DQ. So that is one thing which we have up. Next we have learned about the priority queues. So it is a very special type of a queue into which all each and every element which we are having, that is associated with a priority, right, and that is served according to its priority also. Now there are in total two types of priority queues, ascending and descending. If we talk about the ascending priority queue, so here whatever the elements are inserted, those can be inserted, but only the smallest element it can be removed in from here, right. Now if we're talking about the descending priority queue, so yeah, into this as well the elements can be inserted, but only again the largest element can be removed from the given queue. So that are the respective things which happens up over here into the queues. Right, so I hope I have made this particular thing pretty quite much clear to you all about the queues, that what are the queues, what are different types of queues which we are having, um, generally how do those queues works, what are the practical implementations for the same. I hope I have just made each and every single thing pretty much clear to you. Right, so I hope you have just got out all of the things very clearly. Right, this is all for this video. Till then, thank you and take care.